Good morning, students. Just want to go over these questions from yesterday's assignment to make sure that you understand how to actually do them, because I think there's been a little bit of confusion here on a few of them. So let's take a look. For instance, the first problem says the half-life of zinc is 2.4 minutes. How long will it take for 32 grams to decay to 2.4 grams? So if we're starting with, we're going to make an amount versus time chart. If we are starting with 32 grams, that's at time 0. Well, after 2.4 minutes, we would have half of that, or 16 grams. After another 2.4, or 4.8 minutes, we would have 8 grams. Then after another 2.4 minutes, that would be 7.2, we would have 4 grams. And after another 2.4 minutes, which is 9.6 minutes, we would have 2 grams, which is why 9.6 is the correct answer. So I hope that one helps. For the first one, let's take a look at the second one. It says cesium-137 has a half-life of 30 years. If 1 milligram disintegrates over 90 years, how many milligrams would remain? So if we do amount versus time, we start with 1 milligram at time 0. After 30 years, we would have half of that, or 0.5. After 60 years, we would have 0.25. And after another 30 years, or 90 years, we would have 0.125. So 0.125 was the answer, or 0.125 is also an acceptable answer. All right, the next one is talking about 2.5 grams sample of strontium-90 was formed in 1960. So we have 2.5 grams at time 1960. Every 28 years, we have half of that. So 28 years after 1960 is 1988. So that would be 1.25 grams. And then in another 28 years, so that'd be in the year 2016, we'd have half of 1.25, which is 0.625. So the year would be 2016. If we look at the next one, actinium-227 has a half-life of 29 hours. If 100 milligrams decays over 58 hours, how much would remain? So after 29 hours, we're down to 50. After another 29 hours, or 58 hours, we're down to half of that, or 25. So the answer would be 25 milligrams. Then if we look at these last two, they're a bit tricky, I'm not going to lie. So the selenium problem has a half-life of 25 minutes. So if we have, how long would it take for 10 milligrams to decay to 1.25 milligrams? So at time 0, we have 10. After 25 minutes, we have 5. After another 25 minutes, or 50, we would have 2.5. And after another 25 minutes, or 75 minutes, we would have 1.25. So keep in mind, you start with your time 0, not at 25 minutes. It's an easy mistake to make. You don't want to be the one to do that. All right, so in this problem, we're going to work backwards. So we're going to start with our amount versus time. And what we know is that all the way down at a time of 30 minutes, we need 0.1. So we're going to work backwards. So we've got 27, 24, 21, 18, 15, 12, 9, 6, 3, 0. So those are our times. So we're just going to kind of work backwards and double the amounts. This one was a little bit tricky. So here we'd have 0.2, 0.4, 0.8, 1.6. After that is 3.2, 6.4, 12.8, 25.6, 51.2, and 102.4. So 102.4 is the correct answer. Right. Then the last thing, I think everybody got this right on identifying fission versus fusion. This was not rocket science here. Submarine uses fission. Most powerful weapons are fusion. Japan, we used fission bombs. Nuclear power plants, fission. The sun is fusion. Combining nuclei is fusion, and splitting nuclei is fission.